So, in the previous lecture, I have started process dynamics and control, and already I have told you about all the, you know, important thing regarding process dynamics and control, and I have discussed about the marks distribution and all, and I have also discussed about why we need to study process dynamics and control, right? And after that, I have discussed about the Laplace transform and various Laplace transform uh, formulas for various Laplace transform. Again, first shifting theorem and second shifting theorem already I have discussed. And after that, I have also solved some numericals there, right? So today onwards, I am going to discuss about. So when we talk about process dynamics and control, right? Process dynamics and so I told you. So we are very much interested in knowing the dynamics of the system, right? So I mean, if I want to understand the dynamics of the system, then this particular things requires some kind of identification. And this particular identification has been given by the transfer function. So what happens if I want to understand the dynamics of any particular process, then I'll have to understand what is the transfer function of that process. And once we get to know the transfer function, then we can understand the dynamics of the system, right? So first, I'll be talking about the simplest function, and that is called as the step function, right? I hope you have remembered the formula of all these transfer functions. So when we talk about a step function, how can we define the step function? Just try to understand. It has been defined as the ft is equals to 0 when t is less than 0 and 1 when t is greater than 0, right? This is a step function, right? So the graph will look like this one. So on the x-axis, there will be time, and on the x-axis, we will be having a value of time in this one. So let's say here this one is t is equals to 0. So before t is equals to 0, the function will be 0, and at t is less greater than 0, the magnitude of the function is equals to 1. So this will signify the step function. And this is very important to understand the dynamics of any particular system when we move forward to, derive the complicated dynamics, then you'll need this particular system, right? So now, when we talk about what will be the Laplace of ft, if I want to understand Laplace of ft over here, so there are two functions. So one is Laplace of 0 plus one is Laplace of 1. So Laplace of ft, that is your step function, that is equals to Laplace of 0, I have told you 0, and Laplace of 1 is equals to 1 by s. So Laplace of any step function ft, that is equals to 1 by s, right? And having magnitude of a step function is equals to 1, so that is called as the unit step function. So here I am talking about that unit step function, right? But if I want to give a step input of magnitude m, so how can I talk about it? So the value of ft is equals to 0, and here it will be m when t is less than 0 and when t is greater than 0. Fine. So the plot of this particular step function will look like this one. On the x-axis there will be time, on the x-axis there will be a function value. So this will be like that. And here this particular magnitude will be called as the m, and here t is equals to 0. Now if I want to know about Laplace of ft. So I can write Laplace of 0 plus Laplace of m, right? So here I can write Laplace of 0 plus this m is constant, so I can write Laplace of 1. So this is 0 plus m divided by s. So here Laplace of ft will become equals to m by s, right? So this one is a step function, so of magnitude m, right? Anyone has any doubt? So I'm writing notation of a state function. How we define a step function is, let's say ft is equals to m multiplied with ut, right? So m is your magnitude of, and ut wherever you see that is unit step input, unit, and this one is your step function, right? Now, once you get to know about the step function, then the second function in the section is your, in the succession is your the exponential function, right? So the exponential function ft has been defined as 0 and e to the power minus at. This is some kind of a standard function that you need to understand to, make your problem very easy. So you can write it directly, that is ut into e to the power minus at, right? Because here if it is 0, if it is 1, so it will be ut, and if I will multiply with ut into e to the power minus at, right? So your exponential function will look like, that is ut into e to the power minus at. So this is your unit step function, right? Unit step function multiplied with this exponential function. Now, once we get to know about this function, then I want to calculate Laplace of ft, that is Laplace of ut into e to the power minus at. So in the previous lecture, I have told you about the Laplace of this particular function, right? So how can I calculate Laplace over here? So the magnitude of this function will be 1. So that will be equal to integral 0 to infinity e to the power minus st multiplied with e to the power minus et dt. Fine. So that is equals to integral 0 to infinity e to the power minus s plus a t dt. Right. So that is equals to minus 1 upon s plus a into e to the power minus s plus a into t, and 0 to infinity. So once we substitute the integral limit, so finally you will be getting that value is 1 upon s plus a. So the Laplace of ut into e to the power minus at, you have got 1 upon s plus a. So Laplace of, similarly, we can calculate e2 into e to the power ut into e to the power at is equals to 1 upon s minus a, right? So again, these two formula is very important, that will be frequently used in the successive topic of plant process dynamics and control, right? I hope these things is clear to all of you. Am I audible?
Yes, sir.
Now we have discussed two input function. Now the third input function is, that is ramp input, or you can say ramp function, because these things will be, I mean, used in successive lecture. That's why you should know this function at least. So the ramp function has been defined as ft is equals to 0 in and t when t is less than 0, when t is greater than 0. This is in the form of t, right? Slope. So if I want to, write this function, so I can write that is ut multiplied with t. So your ft is equals to t into ut. So if I want to calculate Laplace of ft, so I can calculate Laplace of t into ut. So I can write integral 0 to infinity e to the power minus st multiplied with t dt. So now this is your Euler's rule. So how can I calculate these things? So that is equals to Euler. So first I'll take t common, integral 0 to infinity e to the power minus st dt minus d by dt of t integral e to the power minus st dt and overall integral 0 to infinity. So this is t and the integral e to the power minus st divided by minus s, that is 0 to infinity minus, here you will see this d by dt of dt is equals to 1, so it will get cancelled out. So this minus minus plus will minus and it will be equals to e to the power minus st divided by s square and it will be equals to 0 to infinity. Any doubt? So once we substitute limit over here, so it will become 0. And once we substitute limit over here, we will be getting 1 upon s square. So finally, you will be getting the value of Laplace of t into ut, that is equals to 1 upon s square, where t into ut, that is ft, that is called as the ramp function. And already in the yesterday I have discussed about in the previous lecture I have discussed about what is the Laplace of t. So I have discussed these things with the normal Laplace kind of thing, and after that we can do this thing. Anyone has any doubt? Now moving towards the next input, that is the sine function. So when we talk about sine function, so that will be equals to 0 sine k2. Just wait 1 second. Hmm? Yeah, so this one is synegetic, fine. So every time you can see, I'm repeatedly doing the same kind of thing when t is less than 0, when t is greater than 0, right? So this will signal, because we are interested in knowing the dynamics of the system. So definitely time will be positive. So definitely time less than 0, that does not make a sense. That's why we are assuming these things is 0, because we have to give some input to the instrument when time is less than 0, because instrument understand these things, right? That's why we have to use this particular thing. Now, so I can write these things as how sine kt into ut. So if I want to write Laplace of ft, so now this is equals to Laplace of sine kt into ut. So can I write that is 0 to infinity e to the power minus st into sine kt, because ut is only 1. So if you are multiplying anything with 1, that will give you the same magnitude. Fine. Now, how can I do this calculation? So which kind of formula I will be using over here? So again, this, what is this? Laplace of these things. So directly can I write that is a k upon s square plus k square, right? That is the same thing. That is sine function. If someone is asking the cos function, So we have to write ft is equals to 0 cos kt when t is less than 0, when t is greater than 0. So your Laplace of ft, that is equals to what? Uh, s divided by s square plus k square, right? So again, this is the thing that we can understand. So already I have discussed all these things in the previous lecture when I was discussing about the Laplace transform. So again, these are some kind of input that you need to understand over here, and that's why I told you over here, right? Now, even if I have discussed about the Laplace of differentials also, so let's try to solve one problem over here. Laplace of differential, how can we solve? So let's say d3x by dt plus 4 d2x divided by dx squared plus 5 dx by dt plus 2x, that is equals to 2, right? And here it is given x0 is equals to dx0 divided by dt, that is equals to d2x0 divided by d2 square, that is equals to 0, right? All these things have been given over here. So you have to calculate the value of x s equals to what? So in the previous lecture, I have discussed you about the formula of differential, and the formula of differential, the Laplace of differential is equals to, let's say, dnf divided by dxn, right? So that is equals to s to the power n fs minus s to the power n minus 1 f0 minus s to the power n minus 2 f dash 0 minus s to the power n minus 3 f double dash 0 and minus so and so forth. So here you, what is your function? Your f is equals to x. Is it clear? So if I want to write f s, so this will be equals to x s, or you can write x s or x s, anything if you want to write. So let's try to understand. This one is d3x by dt3. So definitely here the n is equals to 3. So first I'll write for this particular differential. After that I'll write for this particular differential, and then after I will write for this particular differential, right? And so forth. I can do this particular process for the higher order derivative variables. So let's try to understand for d3x by dt3. So this is s to the power n fs. So can I write x to the s to the power n? So n is your 3 over here. So I'll be writing for s to the power 3 and xs minus next s to the power n minus 1 f0. So x0 is equals to 0. So I can write uh, s square x0 minus again s to the power n minus 2 s0 x0. So f dash 0 is x dx0 by dt. So again s x dash 0, right, minus s to the power n minus 3. So s to the power 3 minus 3 0. So x double dash 0, right? So I have written these things for first one. This is d3x by dt3. Next one is 4 into, now I have to write this for that d2x by dx squared. So here n is 2. So can I write s to the power 2, right? xs minus s to the power 2 minus 1. So s x0 minus x dash 0. Now I have to write for dx by dt. So can I write 5 dx by dt? X is n is equals to 1 only. So I can write uh, s xs minus again s to the power n minus 1, so 0 x 0, right, plus 2 xs, right? And the Laplace of 2 will be equals to what? 2 divided by s. Tell me, anyone has any doubt? Now The boundary condition that has been given over here is x0 is equals to 0, x dash 0 is equals to 0, and x double dash 0 is equals to 0. So here you see x0 is, it will be 0, x dash 0 is 0, x double dash will be 0. Again here x0 0, x dash 0 0, x0 0, and here it is xs. So we are interested in calculating the value of xs. So here xs is there. So I'll take common over here. So this is x cube s cube plus 4s square over here plus 5s plus 2 equals to 2 divided by s. So now how can I calculate the value of xs? So the value of xs, that is equals to 2 divided by s into s cube plus 4s square plus 5s plus 2. So this will be the value of xs. So we have to calculate this particular thing right till now. After that, again, I'll take the inverse Laplace transform and I can convert this S domain into T domain. But I'll be teaching this in the subsequent lecture or today at the end of this particular lecture. But this is the thing that you need to understand, how you can convert a differential equation into the while taking the Laplace transform into S domain, and from S domain we can calculate this particular thing into the T domain, and from there we can calculate the value of this particular x at any particular time, right? Anyone has any doubt in this? Tell me. Is it clear to all of you? Because these things is very important. If okay, so if this is clear, then solve one problem over here. I'm giving you the simplest problem, that dx by dt plus 3x is equals to 0, and if x0 is equals to 2, then calculate x s is equals to what? I am giving you only 1 minute for solving this particular problem. Just do this problem as soon as possible. Anyone has solved it? So this is very simple. How we can solve? Since this is a first order differential, you have to write s x s minus x dash 0, n is equals to 1. So I can write s to the power n x s minus s to the power n minus 1 x0 minus s to the power n minus 2 x dash 0. Sorry. So here it will be x0. Fine. So this is the thing that we can write over here. And finally, plus this is the thing that I have written for this particular differential, plus 3 into xs, and the Laplace of this one will be 0. So we are very much interested in calculating the value of xs. So if I'll take common xs, so this will be equals to x plus 3 minus x 0, that is equals to 0. So your xs into s plus 3 minus x0 is given 2, that is 0. So the value of your xs, that is equals to 2 divided by s plus 3. So we have transformed this particular first order differential equation into the s form. S transform. I mean, after taking the Laplace transform into S form, and after that, I'll be converting this S domain into the T domain later on. But here, right now, we are very much interested in knowing this particular thing, right? I hope these things is clear to all of you. Anyone has any doubt? If you don't have any doubt, then solve one more problem. X double dash plus 4x dash plus 3x plus 5 is equals to 0, right? So calculate the value of xs if x0 is equals to x dash 0 is equals to x double dash 0 is equals to, let's say, 0. If anyone has any doubt, please tell me right now, because if you are not getting this thing, then the subsequent topic will become very difficult for you to understand, right? So again, this requires some. So let's see how we can solve this particular problem. It's very simple. So x double dash is, I can write s square xs minus s x0 minus x dash 0. This is for second order differential plus 4 into, I can write s xs minus x0 plus for this 3 I can write xs plus for this one is 5 by s, that is equals to 0. I'm just only taking this Laplace of whole differential, this particular thing, right? That's it. So now here we can see that x0, x dash 0, x double dash 0 is 0. So this will be equals to 0. This one is 0. This one is 0 again. So I can write s square xs plus 4s xs plus 3x s plus 5 by s, that is equals to 0. So if I'll take common xs, so the thing will become uh, that is x s square plus 4s plus 3 plus 5 by s, that will be equals to 0. So the value of xs, that is equals to minus 5 divided by s into s square plus 4s plus 3. Fine. Anyone has any doubt till now? Is it clear to all of you? Fine. Alina, is it clear?
Yes, sir.
Okay. So, I mean, this is the type of some differential equation that we need to understand, right? So let's try to understand some more, complicated thing. Let's say if I tell you Laplace of 1. So how can you calculate Laplace of 1? So first I'll go 0 to infinity e to the power minus st into 1 dt. So this will be equals to minus e to the power minus st divided by s, and we will integrate 0 to infinity. So that this value will be 1 upon s, right? So this is Laplace of 1 is 1 by s. So if I tell you Laplace inverse of 1 by s, so this will be equals to 1. Tell me. So this is called as inverse Laplace. Laplace inverse of 1 by s will be 1. Let's say if I tell you Laplace of t, how can you calculate Laplace of t? So I'll be doing 0 to infinity, that is function t into e to the power minus st dt. So we are getting the value is 1 upon s square. So Laplace of t is 1 by s square. So can I write Laplace inverse of 1 by s square is equals to t? So Laplace transform, it will convert what t domain to s domain. Fine. And Laplace inverse is used to calculate or convert s domain into t domain. Are you getting it? This is very important thing. So once we know the value of Laplace transform, then we can convert the value of any function which is in the form of t into the s domain, and with the help of Laplace inverse, we can convert s domain into the t domain. This is what Laplace transform is, fine, and this is what Laplace inverse transform is, right? This is Laplace inverse transform, and this is called Laplace transform. So let's say if I want to convert Laplace of, let's say, what? E to the power at. So how can I convert Laplace of e to the power at? So I'll have to write 0 to infinity e to the power minus st multiplied with e to the power at dt. Fine. So again, that product rule will be applicable. So e to the power, if I take minus common, so this will be s minus a t dt. So finally, once we will integrate it, I'll be getting 1 upon s minus a. So this is Laplace of e to the power at. This is 1 upon s minus a. But if I want to calculate Laplace inverse of 1 upon s minus a, so this will be e to the power at. So this one is your Laplace inverse. Are you getting? So this is the way that you can calculate the value of Laplace inverse, right? So let's say if I want to calculate Laplace of uh, sine 80. So the Laplace of sine 80 is, I have told you, a upon s square plus a square, right? So if I want to calculate Laplace inverse of a upon s square plus a square, so this will be equals to what? Sine 80, right? So if by any means, if you are able to convert any s domain function in this particular form, then the t domain of this particular form a upon s square plus a square will be your sine 80. So let's say Laplace of cos bt is equals to what? S upon s square plus b square. But if I want to calculate Laplace inverse of s upon s square plus b square, so this will be giving you cos bt. Fine. So if someone tell you Laplace, calculate Laplace inverse of, let's say, s upon s square plus 25. So see, s upon s square plus 25. So this will look like the cos function. So this will be equals to, I can write that is Laplace inverse of s upon s square plus 5 square. So since this one is your b, right? So I can write this is cos 5t. So Laplace inverse of your s upon s square plus 25, that will be equals to cos 5t. Any doubt? Tell me. It's very important that you have to, process the thing in such a form so that it will come to the standard form, and you have to remember the value of a standard function. I mean, the Laplace transform and the inverse Laplace transform of the standard function, right? So let's solve one problem. So if I tell you calculate Laplace inverse of 2 upon s plus 3, so how can we calculate? So first, if we see this kind of function, so this is your s function. So first we have to see that this is in the form of 1 upon s plus a or 1 upon s minus a. And the Laplace inverse of this one will be equals to Laplace of e to the power what? Minus at. And for this, it is Laplace of e to the power at. Some kind of this function will be there, right? So this is what you need to understand. Fine. Now, always you have to make s is s, and here the thing is there. You have to put this over here in exponential. So let's say this 2 is common, so I'll take 2 common. So Laplace of, can I write 1 upon s plus 3? Fine. So now you know this is Laplace inverse of s plus 3 equals to e to the power what? At or minus at, right? In this form. So your a is equals to 3. So you can write here 2 into e to the power minus 3t. So you can write Laplace of 2 upon s plus 3 is equals to 2 e to the power minus 8t. So you have converted this s domain into t domain over here. Anyone has any doubt till now? It's very important to understand. This is some basic thing. If I mean, definitely you have to be very expert in doing this kind of thing, because every year 2 marks question used to come from this particular topic. So again, this topic becomes very important whenever we solve any problem in process dynamics and control. That's the any doubt. Are you getting it?
Yes, sir.
Okay, so solve one thing. Calculate Laplace transform of 2 into e to the power minus 3t. What will be the Laplace transform of this one? This is t domain. You have to convert into S domain. Convert it and tell me the answer. What is the answer you are getting?
2 by s plus 3.
What? Answer has been written over here on the screen, right? But the essence is that whether you people are getting these things or not, that's the very important thing, right? So I hope you are getting this particular thing. This is some basic things. Now I'll be moving towards, let's say, a differential equation dx by dt plus x is equals to 1, that is given, and the value of initial condition x0 is given. So how will we solve this particular differential equation with this, with the help of Laplace transform? So right now I just discuss about how you can write this differential equation into the s form. So I can write x s minus x0 plus xs, that is equals to 1 divided by s, right? So I will be taking Laplace of dx by dt plus x is equals to Laplace of 1. That's it. That is what I am doing. So if I take common xs, this will be s plus 1 minus x0 is 0. So I will be taking it 0. That is 1 by s. So the value of your xs is equals to 1 upon s into s plus 1. Fine. So now you have got the function in terms of S domain. Now, I am very much interested in knowing that T domain, that is xt. So, how can I do these things? So, I'll be doing Laplace inverse of xs. So, that will give you the value of xt. Fine. So, that will be equals to Laplace inverse of 1 upon s into s plus 1. Fine. Now, we have to convert this Laplace inverse. So, I have told you we have to convert this particular function into any a standard form that we have understood previously. This is s plus 1. So, how can I convert? So, the better way to convert this particular function into the standard form is partial fraction, because this is a mathematical calculation, and this will provide you the flexibility to convert this particular function 1 upon s into s plus 1 in some standard form. So I can write 1 upon s into s plus 1 is 1 upon s plus 1 upon s plus 1. So this is a partial fraction. So I'll be taking a constant a here and taking a constant b over here, right? So if by any means, if I am able to calculate the value of a and b, we will be, we can get the value of a by s and b upon 1 plus s in some standard format of the Laplace transform, and from there we can understand the value of the time domain of xt, right? So let's try to understand how we can solve this particular thing. So here we have got 1 upon s into s plus 1, that is equals to a divided by s plus v divided by s plus 1. So that will be equals to a into s plus 1 plus b into s divided by s into s plus 1, that is equals to 1 upon s into s plus 1. So here I am writing all the steps, but in the gate examination you don't have to write all the steps, right? You have to save some steps. So the value will be equals to a plus b into s plus a divided by s into s plus 1 and divided by 1 upon s into s plus 1. So now, since these things denominator will get cancelled out, so we have to equate the numerator. So in numerator, what can I say? There is no, so this will be equals to a, 1 is equals to s into a plus b plus a, right? This is the simplest way that we can get from here. So now, since there is no s domain, I mean coefficient of s in left hand side, so the value of a plus b will be equals to 0. And since there is constant in left hand side and there is a constant in right hand side independently, so the value of a will be equals to 1. So here a value, this one is equation first, this one is equation second. So I'll be substituting value of a in equation second first. So I'll be getting the value of b equals to minus 1. So here I have got the value of 1 upon s into s plus 1, that is equals to what? A we have got 1 upon s and minus 1 upon s plus 1. So now if I want to calculate Laplace inverse of 1 upon s into s plus 1, that is our main goal. So this will be equals to Laplace inverse of 1 upon s minus Laplace inverse of 1 upon s plus 1. So this is very, very well defined function. This is a standard Laplace transform function. So this is equals to 1 minus Laplace inverse of 1 upon s plus a is equals to e to the power what? Minus at, because this one is your a. So a is your 1, so 1 and t. So you have got 1 minus at. So the value of xt you have got, that is 1 minus e to the power minus t. So now you have got the solution of this differential equation dx by dt plus x is equals to 1 is in this particular form, right? So you have solved this differential equation very easily. So now if I tell you at t equals to 0, what is the value of x 0? So this is 1 minus e to the power 0, that is equals to 0. At t is equals to infinity. So x t is equals to infinity, that is equals to what? 1 minus e to the power minus infinity, that is equals to 1. So this function will be looking like this. Initially it will be 0 and finally it is going to 1. So the maximum value of this function is your 1. So this will be equals to, this function will be like that, right? So this is your time and this is your value of, let's say, ft, and this function ft is equals to 1 minus e to the power minus t. Anyone has any doubt? Tell me. I hope these things is clear to all of you. Fine. So if these things is clear, then solve one more problem. Calculate Laplace inverse of, or it's better to solve some numerical only. I'm giving you one problem. Let's say this is differential equation d2x divided by dt square plus dx by dt plus x is equals to 1, where x0 is equals to x dash 0 is equals to 0. So calculate the value of xt. Xt is equals to 0. Xt is equals to infinity. Calculate this in fast. How we can solve this particular question? Again, we have to use some Laplace transform kind of thing. So again, I can write s square xs minus s x0 minus x dash 0. This is for second of differential plus what s xs minus x0 plus xs, that is equals to 1 divided by s. So again x0 is 0, x dash 0 is 0, x0 is 0. So again we have got the value x s square xs plus s xs plus xs, that is equals to 1 upon s, right? So the value of xs is s square plus s plus 1 divided equals to 1 upon s. So we have got the value of xs, that is 1 upon s into s square plus s plus 1. So now we have got the s domain, right? Once we have got the value of s domain, now we are very much interested in knowing the t domain. So your x domain is 1 upon s into s square plus s plus 1. So xt is equals to what? Laplace inverse of xs. So that is equals to Laplace inverse of 1 upon s into s square plus s plus 1, right? So now the thing is that this is very important. So I have to convert this 1 upon s into s square plus s plus 1. That is equals to, I will be writing a upon s plus, when the partial fraction will be in this form, we have to write bs plus c divided by s square plus s plus 1. Are you getting it? This is just a simple partial fraction kind of thing that you must have studied in BTech or in class 12. So I'll be multiplying a into s square plus s plus 1 plus s into bs plus c divided by s into s square plus s plus 1. So 1 upon s into s square plus s plus 1. So from here we will be getting the value a plus b into s square plus a plus c into s plus a. So now we will be equating the left hand side and right hand side of the constant term and the coefficient of s square and s. So a will be equals to 1. Why? Because here a is constant and here the value is constant is here. So that's why a will be 1. Again, a plus c, that will be equals to 0 because there is no any coefficient of s in the left hand side. So since a is 1, so the value of c is equals to minus 1, right? Now, since a plus b is also equals to 0, we have got the value of a is 1, so your b is equals to minus 1. So the value of your partial fraction, that is equals to 1 upon s into s square plus s plus 1, that is equals to a was 1 by s. Now b, the value of b is minus s plus minus 1 divided by s square plus s plus 1 kind of thing, fine. Now, so you can write 1 upon s minus s upon s square plus s plus 1 plus 1 upon s square plus s plus 1. Any doubt? Now, this is a bit complicated thing. So, you can see here s upon s square plus s plus 1. So you can convert this into the quadratic form. Fine. 1 upon this is s square plus s plus 1 and 1 upon s square plus s plus 1. All these things. So we have separated all these value and you can get this one into the standard form into this one into the standard form. This is already a standard is in the standard form. So the Laplace inverse of 1 upon s into s square plus s plus 1, you can easily calculate Laplace inverse of 1 upon s minus Laplace inverse of s upon s square plus s plus 1 plus Laplace inverse of 1 upon s square plus s plus 1. Right? So this will be the value. This was a bit complicated problem, but yes, you can do this particular thing, right? See, till now, all these things are only process dynamics and control. After that, all these things are mathematics, that is partial fraction, and how you can convert that particular function into the partial fraction, that you must be knowing this things, right? Anyone has any doubt? Tell me. Okay, so if you don't have any doubt, then I'm giving you some simplest question. Let's say your GS is equals to 3 upon S plus 9, 3S plus 9, right? So calculate the value of gt is equals to infinity is equals to what? This is the simplest thing that I can give you. Just calculate the value and tell me what will be the value of gt infinity. Fast. Okay, 0. Let's see. Anyone else? Alina, how much you are getting?
Zero,
Okay.
e
So
raised to
let's see.
minus
This is very simple thing. How can I convert? I will be dividing numerator and denominator by 3. So I will be getting 1 upon s plus 3. Right? So again, this is in the form of 1 upon s plus a. So you're the Laplace inverse of gs, that will be giving you the value of gt, and that is equals to Laplace inverse of 1 upon s plus 3. So this is value of e to the power 3t or minus 3t. This will be
plus
minus
3.
3t. So when I'll substitute g t tending to infinity, so that is equals to e to the power minus 3 multiplied with infinity. So that will be equals to 0. Right? Now calculate if I am giving you gs is equals to 3 upon 3s minus 9. So what will be gt tending to infinity? Tell me. Now you can give the answer in only 2 second, 3 second kind of thing.
Zero,
What will be the value?
zero,
Infinity.
nine, in
Means directly, if you will convert Laplace inverse of, again I'll divide by 3, so it will be equals to 1 upon s minus 3, and that is equals to e to the power 3t, that is equals to e to the power 3 multiplied with infinity, that is equals to infinity. So here what you can see, let's say denominator here and here. What you see, the denominator over here is 3s plus 9. Let's say I will make it 0. So s is equals to minus 9 by 3. Here, if I'll tell s is equals to what? 9 by 3. So if the value of s, that is the root of denominator, is coming negative, then at t tending to infinity, it is coming a finite quantity. But if roots of denominator is, sorry, if roots of denominator is what? Positive, then value is infinite. And here value is finite. So I have seen two things. If GS is called as the transfer function, right? So first, what will I see? Check roots of denominator of GS, that is transfer function, right? So roots will be of positive or negative. If roots are positive, then at t tending to infinity, g t tending to infinity will be infinite. And when roots is negative, at t tending to infinity, g t tending to infinity will be a finite quantity. Are you getting it? This will be infinite and this will be the finite quantity. That is the thing that I wanted to let you know. That is there any doubt? Tell me. I hope this thing is clear to all of you. So, if this is clear, then I'll be discussing one very important thing, that is final value form. So, see, one thing is that what is initial value? If any function y is there, then yt is equals to 0 is called the initial value. Initial value. And when t tending to infinity, y t tending to infinity is called as the final value. You must be knowing all these things, right? Initial value and what is the final value, right? So after that, we used to define a final value theorem. And why we define the final value theorem? That will provide you a flexibility to calculate the final value of any particular function very easily, right? So let's try to understand how we can calculate these things. So if Fs is the Laplace transform of Ft, then we can write limit t tending to infinity Ft. What is this thing? T tending to infinity Ft. This is your final value. Are you getting it? This is your final value of function Ft. And we are very much interested in knowing these things. So first we have to calculate the Ft, and after that we can calculate we will substitute t is equals to infinity and we can get the final value. So the first value, final value theorem tells you that limit t tending to infinity Ft, that is equals to limit s tending to 0 s into Fs. Are you getting? If you know the value, because Fs you will be knowing initially. So let's say you know the Fs. Fs is equal to 3 by 2s plus 5, let's say. Now you are very much interested in knowing the value of Ft of function at t is equals to infinity. So how can you directly calculate? I won't have to calculate this particular Fs into Ft. I won't be, converting this into Ft. Directly, I will be using this final value theorem, and from there, I will be calculating the final formula. So, limit t tending to infinity Ft, that is equals to, I can write limit s tending to 0 s into Fs. So, that is limit s tending to 0 s into 3 upon 2s plus 5. Fine. So if I'll substitute s is equals to 0, this will be equals to 0. So the final value of this particular function will be equals to 0. So again, you are getting rid of, calculating the function, the Laplace inverse of this particular function, that is ft. So final value theorem provides you a flexibility that you can directly calculate the final value of any particular function from S domain only. You don't have to convert this S domain into T domain, and after that you will be substituting the value of T is equals to infinity, right? I hope these things is clear to all of you. Anyone has any doubt? But there is a limitations of final value theorem. So what is the limitation? So roots of denominator of S domain of function fs should be negative if it is real, and second, if roots are complex, then then real part of roots should be negative. If these things are getting satisfied, then only we can use final value. Are you getting it? So only then we can use this final value theorem, right? So first, let's say if a function fs is given, let's say 3 upon s square plus 4s plus 5 or 4. If this is given, so what is our denominator? So this is our denominator. First, I'll check denominator's root. S square plus 4s plus 4, that is equals to 0. So we will be getting s is equals to 2 and 2. Sorry, minus 2 and minus 2. So our root is negative. So if roots are negative, then we can use the final value theorem. Now we can use the final value theorem, and we can calculate ft tending to infinity, that is equals to s multiplied with limit s tending to 0 s into fs, that is equals to limit s tending to 0 s multiplied with 3 upon s square plus 4s plus 4. So if we substitute s is equals to infinity, so definitely it will be coming to 0. Are you getting it? So at t is equals to infinity, this function is giving you the value 0. Because roots are negative, that's why we are able to use this particular thing. Now, try to understand one more problem. Let's say fs is equals to 3 upon s square minus 4s plus 4. So now, whether we can use the final value theorem or not here. So first, what should I do? So I'll be calculating the roots of this function s square minus 4s plus 4 is equals to 0. So we will be getting s is equals to 2 and 2. Since the root is positive, so we cannot use final value theorem, right? We cannot use final value theorem. So now if I want to calculate what is value of function ft is equals to infinity, then you have to calculate the Laplace inverse of fs. So that is equals to Laplace inverse of, again, basic things that what I have told you, s square minus 4s plus 4. Again, you have to convert this into the partial fraction, that is s3 upon s minus 2 into s minus 2, and that is equals to a upon s minus 2 plus b upon s minus 2. So again, I'll substitute this value s minus 2 plus b into s minus 2 divided by s minus 2. Fine. So into s minus 2, let's say. So that will be equals to a plus b into s minus 2 into a plus b. Fine. Divided by s minus 2 and s minus 2. So the value of a plus, here a plus b into s minus, okay, it's fine. So finally, I mean, while doing this particular thing, you can calculate the value of a and b. So once you will calculate the value of a and b, you will be substituting the value over here, and again you will be calculating the Laplace inverse of this particular thing. So let's say what will be the value of a plus b over here. I mean, want to calculate the value of a plus b. So your a plus b here, a plus b is equals to 0. That is your equation first, and that is again here it is s, a plus b into s minus 2 into a plus b is equals to 0. So your here a plus b is equals to minus 3 by 2. I am doing something wrong, right? Minus 2a minus 2b. It will be common, and a plus b. So, oh, okay. So it will be equals to, here it will be minus. Sorry. Let's say by any means you are able to calculate the value. Let's say we have got the value of a is 1 and value of b is equals to minus 2. Let's say I've got this, so right? So here I'll be getting 1 upon s minus 2 minus what? Value of b is minus 2. In actual problem, you will be getting actual answer s minus 2. Fine. So again, if I'll convert Laplace inverse of 1 upon s minus 2 minus 2 into Laplace inverse of 1 upon s minus 2. So this will be value of what? E to the power 2t minus 2 e to the power 2t. So that is equals to minus 2 e to the power 2t. Sorry, minus t e to the power 2t. So when this is now your gt, that is minus e to the power 2t. So when t tending to infinity, what will happen? Your gt tending to infinity becomes equals to minus infinity. So again, this is coming undefined. So the thing is that the essence of doing this particular thing is that if I told you if roots of denominator is positive or real parts of denominator is equals to positive, then final value of the function will be infinity or infinite kind of thing. I'll tell you later on in this particular topic that I'll be calling this particular system as an unstable system. Which particular system is called as a stable system depends upon the value of the final value of the particular function, right? Anyone any doubt till now? Tell me. Anyone any doubt in understanding the final value theorem? Okay, if there is no doubt, then we'll solve one more question on the final value theorem, and that is the xs of the function is given as 1 upon s into s cube plus 3s square plus 3s plus 1. So calculate x t tending to infinity is equals to what? How can I calculate? Tell me the value. Anyone is getting answer? So how can I calculate? So this one is s and s cube plus 3s square plus 3s plus 1. So your denominator's root is equals to s is equals to 0 or s cube plus 3s square plus 3s plus 1 that is equals to 0. So this one is s plus 1 whole cube that is equals to 0. So s is equals to minus 1. So here you see that the roots of denominator is coming minus 1, and this will be repeated root triplet, that is minus 1, minus 1, minus 1 and 0. So this here I have told you, if roots are coming negative, then we can use the final value theorem. So if I want to calculate xt tending to infinity, so I can write limit x tending to s tending to 0 s into xs. So that is equals to limit s tending to 0, here s multiplied with 1 upon s into s cube plus 3s square plus 3s plus 1. So this s and s will get cancelled out, and after that if I'll substitute the value of s is equals to 0, so you will be getting the value of function is 1. Fine. This one is one way where we can use the final value theorem, because here the roots are coming negative, so we can use the final value theorem, right? But if you are not getting any idea whether if I can use the final value theorem or not, so you have to go through the basic method. So again, if I want to calculate, if xs is given, that is 1 upon this was x and this was s plus 3 whole cube. Fine. So again, if you want to calculate xt, so that is equals to Laplace inverse of your xs, right? So that is equals to Laplace inverse of 1 upon s into s plus 3 whole cube, right? So you can write Laplace inverse of I mean this is your function, so I you have to break this function into partial fraction. S plus 3 whole cube, that is equals to a upon s plus b by s plus 3 plus c by s plus 3 whole square plus d upon s plus 3 whole cube. Now from here you can calculate the value of a, b, c and d. How you can calculate? So again you will be multiplying this is s into s plus 3 whole cube. So a into s plus 3 whole cube plus b into s plus 3 whole square plus c into s plus 3 plus d into s. So now from here you will be getting the equation in terms of if three equations in terms of a plus b plus c, something kind of that, and you will solve, you will be getting the value of abc, and once you substitute the value of abc over here, again you have to tell that Laplace inverse of a upon s plus Laplace inverse of b upon s plus 3 plus again Laplace inverse of c upon s plus 3 whole square plus Laplace inverse of d upon s plus 3 whole 4, right? So in that way you can calculate this particular value of the function. Are you getting it? So, I mean, the best way is to, I mean, see the function, try to understand the roots of denominator of the function. If roots are coming negative, if this is real, and if the roots, I mean, if roots are imaginary, so you have to understand that the real part of the imaginary roots would be negative. And if it is negative, then definitely the function, we can use the final value of theorem. And with the help of the final value of theorem, we can calculate the ultimate, that is the t is equals to infinite, the value of function at t is equals to infinity, and we can understand whether the function is stable or not, right? Any doubt? Anyone any doubt? So one more confusing thing over here is that I have told you here right now. Here you don't see s is equals to 0. So if the function is in this form, then you have to understand that c roots of s into xs, right? Always try to see the roots of s into xs. Fine. So you will eliminate this s, and after that you can calculate this value, right? So always try to see roots of x s into xs. Fine. And the roots of denominator. So how these things comes, let's try to understand one thing. How final value theorem comes. Right? So let's say if there is a function 0 to infinity df dt into e to the power minus st dt. So see, let's see one thing. Df dt. I want to calculate Laplace inverse of df dt, right? So Laplace of df dt. So if I want to calculate Laplace of df dt, so what can I write this formula? That is equals to 0 to infinity df dt into e to the power minus st dt. This is the simplest thing that I can write in form of the Laplace, right? So the value of Laplace of df dt, what can I write? Laplace of df dt here I am writing that is equals to 0 to infinity df dt into e to the power minus st dt. So Laplace of df dt I can write s fs minus f0. So once we do this integration over here, so what will I get here? Tell me. Since this is the integral, so directly if I say you to integrate these things, so you will be getting the value of that integral ft minus f0, right? And here you will be getting limit t tending to infinity. So s into fs minus f0, that is equals to limit t tending to infinity ft minus f0. So here you can use limit s tending to 0. So this f0 will get cancelled out. So finally you will be getting limit t tending to infinity ft is equals to limit s tending to 0 s into fs. So here you are seeing, you can see there is a value s into fs. So always try to check the roots of denominator of s into fs, right? So it will give you less confusion about this particular. Is it clear? Now, if these things is clear, then I'll move forward towards the initial value theorem. Similar concept is there, that initial value theorem. What we do in initial value theorem, limit t tending to 0. We are very much interested in find the value of function at t is equals to 0, ft. So that is equals to just opposite of that final value term, s tending to infinity, s into fs. That's it. Fine. S into fs. That's it. This is your initial value theorem. And what final value theorem was? Final value theorem. This was limit s tending to 0, sorry, limit t tending to infinity ft, that is limit s tending to 0 s into fs. This was your final value theorem. This becomes very important when we try to calculate the initial and final value of a particular theorem. I mean, for a function, right? Anyone has any doubt till now? Tell me. So only you need to remember this particular thing. These two function that is very important that you need to remember, right? So before moving forward, I'll be giving you some questions and you have to solve this question. So calculate x0 if xs is given, that is s4 minus 6s square plus 9s minus 8 divided by s into s minus 2 s cube plus 2s square minus s minus 2. Calculate the value of x0. What is x0? At t is equals to 0. Fine. So again, for inverse Laplace transform of 1 upon s square plus 1. Either you break this particular term into the this form. Let's say s square plus s plus 1 is equals to 0. So what can I do over here is either you break this is a quadratic, so you can calculate the root of this quadratic equation, or you can write a plus bs upon s square plus s plus 1, right? A plus bs upon s square plus s plus 1. Or it's better, you can write, if you want to calculate this Laplace transform of this particular function, so I can write 1 upon s plus a, s plus b, right? And you can calculate the value of a and b finally. And after that, you can write a upon s plus a plus b upon s plus b, right? How can you calculate a plus value of a plus b, right? So the value of a plus b is equals to what? A plus b is equals to 1 and ab is equals to 1. Are you getting it? So from here you can calculate the value of a and b for this particular function. Now substitute the value of a and b. You calculate the value of a and b, capital A and b. And after that you can calculate Laplace inverse of a upon s plus a plus Laplace inverse of b upon s plus b. Are you getting it? How can we calculate? So these things you do at your home, right? You should calculate this particular thing. Are you getting it? I have told you the method. How can you use? This is just a simple mathematics. You people can do these things, right? So do at your own and solve this particular problem right now as soon as possible. I am giving you only 2 minutes for this. I am asking the initial value of this function. So first you have to understand whether we can use initial value theorem or not. And once you have I mean, if it is suitable for using initial value theorem, then definitely you can use. And if it is not suitable, then you have to go to, calculate the value of xt while using the partial fraction. And once you do the partial fraction, you have to calculate the constants value. Once you do the calculate the constants value, you can calculate the functional value at any particular time, right? So just do the math. How much answer are you getting? So let's say how we can solve this particular problem. So since we are very much interested in knowing the value of function at t equals to 0. So let's check whether this function we can apply the initial value theorem or not. So first we have to check the roots of denominator. So I have told you check roots of s into xs, right? So s into xs, that is equals to some this particular value. So I'll be checking the roots of s minus 2 into s cube plus 2s square minus s minus 2. So since, see, try to understand one thing, most of the parts of, process dynamics and control is based on the calculation of the roots of the denominator. Once you are very much, dexterous in calculating this particular thing, definitely the work will be very easy for you. So try to, understand these things. The roots will be at 2. So s cube plus 2s square minus s minus 2. So again, here if I'll take common s square, so it will be s plus 2. And here if I'll take minus 1 common, so s plus 2. So roots will be minus 2 and s square plus 1. So plus minus I. Are you getting it? So since here you can see that the roots here is coming, here one positive roots is coming, one positive root we are getting, and here a root of this particular thing, right? So I have told you we have to understand the real part of the complex root, but here there is only imaginary part, so don't bother about these things. So here we are getting a positive root. So once the positive roots are there, then definitely the initial value of this function will be equals to infinite. I mean, again, the thing is that, sorry, so we have to calculate the initial value, fine. So how we can calculate the initial value? So the thing is that uh, till now we cannot use final value, the initial value theorem, right? Because root is coming positive. So now how can we calculate the value over here? So we have to substitute the value at s is equals to, because we are very much interested in knowing the initial value, so s is equals to infinity. So let's try to understand these things here. Here I am writing limit s tending to infinity s into xs, that is equals to limit s tending to infinity. So this is your s4 minus 6s square plus 9s minus 8 divided by s minus 2 into s cube plus 2s square minus s minus 2. So if I'll multiply these things inside, so this will be equals to s4, fine, and s4, and the numerator it will be also s4 kind of thing. So if I'll divide by s4 both sides, so and after that I'll substitute as tending to infinity, so we will be getting the value 1. Are you getting it? How I am getting? You multiply this by s minus 2 and all these things. So finally you will be getting here in the denominator s4 plus something term. And here you are getting s4 plus something term. So I'll divide numerator by s4, denominator by s4. So remaining term will become 0. Remaining term will become 0. So this s4 by s4 will become equals to 1 divided by 1, that is 1. This is how you can calculate the value over here. Are you getting it? This is just a simple mathematics you can do here. Anyone has any doubt, you can ask me right now. So if there is no doubt, then solve one more problem. That is, this kind of problem is very important. So calculate if your fs is given as 1 upon s plus e to the power minus s minus e to the power minus 2s divided by s square minus e to the power minus 3s divided by s. Then calculate the value of ft. I want to convert s domain into t domain. So what is this? This is your inverse Laplace. So you have to convert Laplace inverse of fs, that is equals to ft. So you have to convert Laplace inverse of 1 upon s plus Laplace inverse of e to the power minus s minus e to the power minus 2s divided by s square minus Laplace inverse of e to the power minus 3s divided by s, right? So now you try to understand how we can calculate this Laplace over here, Laplace inverse. So tell me Laplace of e to the power at, that is equals to what? 1 upon s minus a. Laplace of e to the power minus at, that is equals to 1 upon s plus a. So can I write Laplace of t into e to the power at, that is equals to 1 upon s minus a whole square. Laplace of t into e to the power minus at, can I write 1 upon s plus a whole square? Any doubt? Tell me, anyone has any doubt? So how can I do this particular thing? Any idea about this?
So a square can be written as square plus 1 and minus 1, sir. Then we'll simplify according to that.
Okay, let's say, I mean, these things will be very difficult to calculate manually, right? So if I tell you calculate the initial and final value of this theorem, I mean, they have asked about initial value and final value of theorem. Calculate these things. So how can we calculate the initial and final value? So because conversion of this particular S domain to T domain will be tough to write right now here. So I'll be taking S into Fs. So the value will be 1 plus e to the power minus S minus e to the power minus 2s divided by S minus e to the power minus 3s. So I'll be substituting limit S tending to 0 S into Fs. So that is equals to, if I'll substitute S is equals to 0, so what will happen? 1 upon S, that will become make this particular thing infinite. So the final value is your infinite. So this is unstable system, right? This is your unstable system. So I'll be applying here, that is the final value, initial value theorem. Anyone has any doubt? Okay. So let's try to understand one more thing that is very important. I'll be talking about only this particular problem. Let's say I tell you unit step input. What does it mean? That u t. What will be the plot of this function? So this function, the plot will be like that, right? Let's say ft. Ft is equals to ut. So this plot will look like, the plot of this unit step function will look like this one. At t is equals to 0, there will be a step input of 1 unit, right? Fine. But if I want to tell you, draw a function profile ft is equals to u t minus 3. So how we can draw? So the value, the function profile you can define over here is, at t is equals to 3, you have to make this particular thing 0, and this will be your functional value, this will be your t. So if I'll take t is equals t minus 3 is equals to 0, so your t is equals to 3. So at t is equals to 3, you are giving a step input of u 1 unit. Are you getting? So if the plot is like that, then you can say this is u t minus 3. Are you getting it? So let's say if I tell you, if I am drawing a plot like that, if this is t and if this is ft, and right, if this is 2 and if this is t is equals to 3. So how can I plot this, but I mean, how can I write this function ft? So let's say this one is 1 unit and this one is also 1 unit, right? So what is happening over here? So here this one is 1 and here let's say this one is your 2. So I can write at t is equals to 2, you are giving a unit step of unit bit 1. So u t minus 2 plus again at t is equals to 3, you are giving a unit step here to u t minus 3. Are you getting it? So you can write this function in this form. Let's say I tell you, if this is a function over here, if this is t, this is ft, and if I tell you this one, this one. So let's say this one is 2 and let's say this value is 1, t is equals to 1 and this t is equals to 2. So how can I write ft? The ft can be written as at t is equals to 1, I am giving a step input of unit 2. So I will be writing 2 multiplied with u at t is equals to 1. So t minus 1 over here. And but again, this was here 2 input. Again here I have given at t is equals to minus 1 input, right? So minus 1 into u t minus 2. So the value will be u t minus 1 minus u t minus 2. Are you getting? Here it was 2, and here at t is equals to 2 I gave 1 unit negative input. So it will come here and it will go like that. So the magnitude here is minus 1. That's why I have written over here is minus 1, right? Any doubt? One more thing. Let's say I will make more complicated over here. Let's say this one is your ft. This one is your t. Right? Let's say this one is t. Wait 1 second. I don't know what is happening. Let's say okay, no issue. I think my pad is not working right now, so I'll end the class till now, right now. So again, in the next lecture, tomorrow onwards, I'll be discussing about some complicated problem regarding unit step input. Again, I'll be moving forward towards some different kind of inputs and all, and we'll be solving some problems. So I'll post some questions of process dynamics and control. And if you people are having Kafner book, you can solve the problem of chapter number, you know, part first. You can solve lots of problems are there. You can solve that problem, right? Okay. Thank you all for attending the class. Thank you. If any doubt you can ask, otherwise you can leave the class.
Sir,
Yeah, ask.
so with respect to the x-axis, the value is increasing to 2, no, sir, in the first case also. So it will be u into t minus 2 plus 2u into t minus 3, no, sir.
Where here?
Yes, sir,
No,
starting example.
no. See, at t is equals to 2, you have given is unit input, right? So u t minus 2, fine. After it went to t is equals to 3. Now here you have given one step input over here. How much input you are giving over here? Only
According to
one,
the
na?
input, we'll put.
Yeah, only
Yes, sir.
input you have to put. Here you have given one input. So I mean this function has considered this particular value, right? After that again there is a addition. So you want to consider only this value. So just forget these things. What is this? Here only you have given one input. This is another function, and where you are giving at t is equals to 3. That's why one input 1 into u t minus 3. Are you getting it?
Yes, sir.
Yeah, only you have to consider in the input you are giving, right? The magnitude of input. Okay.
Okay, sir.
Okay. So thank you then for attending.